Hi, everyone. This is Nihar Bihani. I'm a Senior Product Manager on the Amazon CloudFront team here at Amazon Web Services. And I just wanted to walk you through the agenda today, and then we'll take you through the content, and we'll leave plenty of time at the end for Q&A. So in terms of the agenda, my colleague Mark, he will be starting off the presentation, and he will talk about the major components of streaming media stack, in terms of from a broad industry perspective, what we see and hear from different customers. And he'll really set the context for the rest of the presentation. Once Mark is done setting that context, I will come in and talk about how the rapid increase in viewership using the different devices out there today has posed a set of challenges for you as a media publisher. We'll touch on how many publishers are handling this complexity today. What are some of the issues there? And then what are some of the best practices that we've learned over the years from working with these customers, and how you can use these best practices to stay competitive in this environment. And finally, we'll talk about how you can use AWS and the various services that we have available at AWS to implement some of these best practices. So I'll hand it over to Mark at this point.
Thanks, Nihar. So switching, oops, sorry, need to go back one slide. Okay, so today, we're going to mostly focus on how you do video streaming and video delivery. But prior to that, there's more of a media workflow. So you have to deal with the entire workflow, everything from ingest to storage to processing, and then we can start to talk about the delivery aspects a little bit. So I'm going to focus on some of the components that make up the entire workflow, and then I'll hand it back over to Nihar to talk about some of the streaming components. So first, let's talk a little bit about the ingest piece. So traditionally, media companies are going to have large on-premise storage. Typically, that's been driven through needs around security, and they often have tiered storage solutions, everything from working storage for things like edit bays, where they need high-speed connectivity, fiber channel connectivity, local SAN storage. Maybe they'll have a little bit bigger storage for current catalog, and then maybe even offline storage for archive. So things like tape storage, and maybe that's off-site even. But the content owners are finding that for a variety of reasons, they can't really keep up with their storage requirements. Everything from the fact that there's more and bigger content, so whether it's just more content from different sources, there's lots of not only traditional kind of network type content, but the cable and satellite providers have hundreds of channels available now. There's user-generated content. There's more coverage of different events, whether it's live sporting events or other. But that content, even though there's more content, there's also larger content formats, right? So as people have moved from standard definition to high definition to 3D, and now we're getting into 4K, and it's just going to continue to grow. The combination of those two factors are causing storage requirements to really exponentially explode. So if you start thinking about those issues, you need to figure out how to get that content moved up into a cloud environment. And that may be through a number of methods. You can use traditional, just push it over the internet with things like FTP. There's accelerated software solutions for pushing content, things like partner solutions that we have with the Amazon Web Services platform from companies like Aspera, Signian, or Cloudbeam from Attunity or others. There's lots of solutions out there for that. There's also ways to do direct fiber connections directly into the cloud-based infrastructure. And then, some people still want to use the old school sneaker net, literally ship drives and have those ingested by the cloud provider. So there's lots of ways to get that content into the cloud that can, depending on your needs, you can speed that up significantly. So let's talk a little bit about the storage and archive aspects. So I've already kind of mentioned, not only do you need additional growing storage for the different types of content, for more content and the larger content, but when you start working with content, once you've got it up in the cloud and you start processing it, you start thinking about all the different types of outputs that you're going to need, different renditions of that content for different device types. And that can be whether those devices support different codecs, different container formats, different streaming protocols. Maybe they have different screen sizes. You need different resolutions. There's a lot of factors there. So in addition to all the storage that you need for the source content, you now need to think about storage for all those output device renditions as well. Durability can be a big issue. I think when you're talking about on-site, on-premise type storage, you're often in a situation where you need to have multiple copies. In the cloud, we can take care of that automatically for you, so you don't really have to worry as much about having multiple copies. If you store your content up in like Amazon's S3 storage, it's got 11 nines of durability, so you can get out of the game of having to deal with multiple copies of content, and that can really save people a lot of time and expense as well. But you might also want to have ways to automate, right? So a lot of times you'll have big content libraries, and it's not usually the case that people using the cloud for media processing and distribution are talking about one marketing video for a homepage on a website. They're usually talking about large content libraries that they need to process and distribute at scale. So how do you deal with some of that stuff in an automated fashion? On the storage side, you may want to set up policies for how you do lifecycle management. For instance, let's say you have some content library and you want to keep track of how often that content is accessed. Let's say you want to set up a policy that says, okay, if content that's in my primary storage isn't accessed for 30 days, let's automatically shift that down to archival storage so that you can save costs on the storage aspect. So archive storage, typically is going to be a lot less expensive than current catalog storage or kind of that nearline storage. The other thing is, you want to really look into making sure that you've got compatibility with all your existing solutions. So, having a rich ecosystem of partner solutions available as part of the platform where you store your content can really be an important aspect. The concept really comes down to what a lot of people call content gravity, right? So once this big content gets moved up into a cloud environment, it's going to probably stay there for a long time. And that's, for the same reasons that we were talking about earlier, is that content can be slow and expensive to move around. But what happens there is that content will get up into a cloud environment, and because these cloud environments are typically open platforms where third-party solution providers can come to the platform and bring their solutions to the platform, you'll see these third-party solution providers flock to wherever that content is stored, and they'll want to be part of that value chain. They'll want to be able to participate in processing and distributing that content. And what you'll see is that over time, very, very quickly, that will become a virtuous cycle. So the more content that's on a particular platform, you'll see more and more solution providers come to that platform to participate in the value chain, and then you'll see more content providers putting their content there because the solutions that they know and trust and have used for years are available on that platform. So moving on, this is just a quick block diagram of what a typical storage, ingest and storage architecture might look like. So you can kind of see down at the lower left-hand side, you've got your content files as well as your metadata. So the content files are coming into the S3 storage, which is up kind of in the upper middle there, that big box, coming into the storage via maybe a fat pipe like Amazon's Direct Connect service, which is a direct fiber connection into our infrastructure, or maybe you're using one of those software-based accelerated solutions. On the right-hand side, you've got metadata coming into content management servers and maybe being backed up by a database on the back end there. But pretty straightforward architecture. But this picture really is just to give an idea of what some of the AWS services might be that you would use to do a traditional ingest and storage architecture. So let's talk a little bit about the processing side of things. Now that we've got the content ingested and stored up in a cloud environment, you need to start thinking about how are you going to process all these files. So typically you're going to bring up either full resolution source files, ProRes things, or other formats, or you may be bringing up mezzanine level files. So for those that don't know what a mezzanine level file is, it's basically going to be a file that's got resolution that's at least as great or greater than your most demanding target output device. So once you get the files up into the cloud, you're going to need to transcode those or transmux those, so putting them into different container formats. So the transcoding piece is really about how do you get the source files or the mezzanine files transcoded into the appropriate codecs at the right bit rates and the right screen sizes. And then once you get that taken care of, you can start thinking about what's the packaging mechanism, the file container traditionally, that is used for the different delivery protocols. And we'll get to the delivery protocols in a little bit. But traditionally, people have used a number of different delivery protocols. Some of them have had pretty good lifespan in the industry, but there's been issues that people have run into for some of the traditional stream protocols like RTMP or some of the older like MMS and other proprietary protocols where because they weren't HTTP based, they wouldn't necessarily have as easy of a time getting through firewalls and things like that, and it was also difficult to scale those out through a content delivery network. So most of the newer video delivery protocols, you saw some of those in the first survey question at the start of this talk. Things like Apple's HTTP live streaming or HLS, Adobe's HTTP dynamic streaming or HDS. You got Microsoft Smooth streaming, and then you've got standards efforts that are coming out, things like MPEG-Dash. So all of those adaptive bitrate streaming formats traditionally have the concept of segmentation. So it's basically taking the file at the appropriate bit rates and chopping it up into a number of segments, anything from a couple of seconds up to 10 seconds or more, depending on what's optimal for the delivery protocol and the output device. So there's a couple of different ways to do that segmentation. You can do file level segmenting and virtual segmenting, and we'll talk a little bit about that in a minute. So moving on to the next slide, I just want to talk a little bit about, I'm not going to go into this eye chart in a lot of detail, but the idea behind video and audio codecs. Traditionally, a codec is really about, it's an acronym for compressor and decompressor. So when you're taking source level video or audio, you want to compress it so that you can save space or make it easier to transmit the content over a limited network connections. So typically there's two kinds of codecs that people use, lossy and lossless. And so lossless codecs means that you can compress the file down some amount, and then when you decompress it, you still have all of the information that was originally contained in the source file. So you don't lose any quality is what it comes down to. Lossy compression is where you actually do lose some of the information, but usually it's you use that in a situation where it doesn't matter. So if you have like a HD level source file, but you're only delivering it to phone screen size devices, you can reduce the quality of that through lossy compression and save a lot more space for storage and delivery. Now, basically, you're going to want to use lossy compression schemes for the delivery side and use lossless for anything that's prior to delivery, things like editing and capture and things like that. What we're seeing, since we're talking, in the context of video streaming today, what you're typically going to see these days is most people are using lossy compression for the video. They're using H.264. For the audio, it's typically HEAAC, and that's oftentimes found in an MP4 container file. So, like I said, don't want to go into too much detail there, but just want to give a little bit of background. Hopefully that's not anything new for all of you. I mentioned the MP4 container file here, so this slide basically is a list of some of the traditional container formats, and I guess it's ordered from sort of most recent down to some of the older ones. But you're going to find most people delivering video these days are going to be using the MP4 container. It's traditionally or historically has its roots in QuickTime and Adobe Flash, so it's very pervasive in the market. You'll still see some things being delivered through other formats, like WebM and Matroska. Things like MKV files, you see a lot of that as well. Some of the other formats listed here, like ASF, is Microsoft's advanced streaming format. It's a little bit of an older format that they used to use for Windows Media Technologies. AVI actually preceded that one from Microsoft as well. And then FLV is basically the Flash video container as well. So I think this slide is a little bit more interesting. The codecs and file containers are pretty low level, and most people are standardizing on H.264 AAC and MP4, but the protocols are really where it starts to get interesting from a streaming perspective. We've had traditional protocols, like I said, that were not HTTP based, that had some issues with delivery. But if we start at the top of this list, you look at things like progressive download, which is what YouTube has used for a long time. I know YouTube is starting to move into some of the adaptive bitrate protocols as well now, but traditionally progressive download simply means you've got a file on a web server somewhere, the user clicks a link, it points to that file, it downloads the file to your local computer, and then plays it back. The problem with something like that is that if you don't have a streaming server or download server that's intelligent and have communication back and forth with the player, you can end up downloading a lot more of the file than necessarily the end user is going to play, which ends up costing you a lot more. If you start looking at some of those other traditional streaming protocols, RTSP and RTMP and things like that, you start to get into a situation where you're only delivering the content that is actually consumed by the end user, so you don't have that situation where you're downloading more information and paying for more download than they're actually using, so that helps with that. But there's drawbacks there with, like I said, some of the protocols had trouble getting through firewalls and other things weren't scalable through content delivery networks. We started to get into some of the things around pseudo streaming, which was HTTP based, but it also required some intelligence on both the player and the server to make it happen. So that had its drawbacks as well. Just for completeness, I've got a bullet in here about radio streaming, so some of the proprietary protocols there around Shoutcast and Icecast and things like that. They just didn't work that well with CDNs. This last bullet, though, is really where I think we're going to spend the bulk of the time today, and that's about adaptive bitrate streaming protocol. So adaptive bitrate streaming, as I mentioned before, you take basically your source file, you transcode it into a number of bit rates. So you might have one target bit rate that's optimized for phone-type screens. You might want to have one that's a little bit higher resolution for tablets, or one that's a little higher resolution for PCs, or maybe your game machine hooked up to your TV at home. But the idea is that you end up with typically kind of 4 or 5 or 6 or 7 different bit rates that are optimal for your target audience. And then once you have those bit rates available, there's also a file that's traditionally called a manifest file that kind of describes what those files that are available are and where they can find the various segments or chunks of those files. So adaptive bitrate streaming protocols, there's kind of 4 flavors. Microsoft Smooth Streaming is typically what you'll find for reaching devices from Microsoft, so things like the Xbox and Windows Phone and Silverlight and things like that. Apple's HTTP live streaming, or HLS, is great for iOS devices, and most of the newer Android devices do support HLS, but there's lots and lots of different levels of support on the device layer on the Android devices for HLS, and so you've got to be fairly careful. I mean, I think a lot of people will think that the device says it supports HLS, so I can just transcode all my stuff and package it up into HLS at whatever version of that spec, and it should work on all these devices, and it's not always the case. There's a lot of nuances. Adobe's HTTP dynamic streaming, or HDS, is traditionally been used for reaching Flash-based clients, and that's largely been driven towards PCs, as Flash is not as available on devices these days. I think HDS is a protocol that is losing some steam to HLS and others. Then MPEG-Dash is an industry standard that's kind of emerging. It's been the specs and things have been developed for a number of years now, maybe 3 or 4 years, but it's really starting to catch on a lot more at this point. Just last year there was some efforts to tighten up the spec a little bit to basically develop the Dash 264 implementation, which was an interoperability subset of the spec, and it's making it so that more and more tools providers and content owners are now able to start delivering content in that format. So I think time will tell, the pervasiveness of that. I think at this point, HLS is clearly the leader in the industry from a protocol perspective, and I think although Apple's been involved with MPEG-Dash, I'm not sure what incentive they have right now to move away from that. So like I said, time will tell on the different protocols, but HLS and MPEG-Dash are kind of leading at this point, but then Microsoft Smooth Streaming is also big as Xbox and other Microsoft platforms continue to have popularity. So let's talk about how you actually generate the streams. So like I said earlier, there's kind of 2 different ways to do this. So you can pre-encode the files and then deliver them directly from storage. That oftentimes can be a good thing to do. So for instance, you can take your source files, transcode them into the various bit rates, and then segment them or chunk them up into the little chunks and store all those little chunks and manifest directly in storage, like on Amazon S3, and your web page or player can point directly at those files or at that manifest in storage and deliver it straight out of storage. It's a hugely scalable solution and very straightforward solution. It doesn't require having an origin server like a Adobe Media Server or Microsoft IIS Media Services or anything like that. It's just coming straight out of storage, so it makes it more scalable and there's less complexity there. However, there's also solutions, like I said, with Adobe Media Server, or, Microsoft IIS, or Wowza, or things like that, where you can just put the source files up there, and as part of that origin server, it will actually take care of the chunking, the segmentation of those files into the appropriate chunks, and then stream those out dynamically. And oftentimes, you'll need to do that for live video scenarios, or if you want to have additional control over that. But it does require that you run and manage that origin streaming server. Just a quick slide here, a bit of a block diagram. Same thing with as we started to get into the delivery aspects. So really what this is showing is how you would do an architecture for delivering both, or all 3 actually, HLS, HDS, and smooth streaming through a content delivery network like CloudFront from Amazon. But basically it's a fairly straightforward architecture, and you can deliver to almost every device on the planet by just having those 3 back ends. Or again, if you want to unify those things, you can have other partner solutions like Wowza has that will be able to deliver all those protocols out of one back-end server. Just from a players and devices perspective, this is really one of the big challenges, and I think one of the reasons why a lot of people are moving to the cloud for delivering media is that there's just so many devices available now, whether it's phones and tablets and gaming devices and smart TVs, and you name it. There's so many different flavors of devices. You got to make sure that you've got a player on those devices that can consume the content in whatever protocols and formats that you're developing. So it's a pretty big consideration, and it's one of the things where we've got partners that deliver video at scale using Amazon Web Services platform, and they'll actually transcode each source file into sometimes over 100 different output formats for each source file, just so they can reach all these devices and make it a great experience. So just something to keep in mind there. From a security perspective, traditionally each streaming protocol and format has its own proprietary security solutions. So things like Microsoft Smooth Streaming works with Microsoft PlayReady DRM. Adobe has their Adobe Access product. There's a number of different third-party DRM solutions. The thing about content protection is that I think a lot of people used to think it's more of a black and white, it's either on or off kind of thing, but really it's a speed bump, and the size of that speed bump should be commensurate with the value of that content. So there's a lot of different things that you can do, whether it's signed URLs or token generation or full DRM systems, but it really kind of comes down to your specific needs for your type of content. For instance, most people aren't going to DRM the nightly news because it gets stale very quickly and there's not a lot of value to it. But for a first-run Hollywood movie, you're going to want to have a full-fledged security solution. So with that and laying down that context, I'll hand it back over to Nihar to talk about the challenges of media streaming beyond the desktop.
Great. Thank you so much, Mark. So like Mark said, I'll talk briefly about the challenges of media streaming beyond the desktop. But what I want to spend the majority of our time, the remaining time, is talk about the media streaming best practices and how you can use AWS and the various AWS services available to implement some of those best practices. So as Mark already alluded to, when it comes to delivering your video content seamlessly to every potential viewer out there, it's a huge challenge today, and that's because of the fragmented ecosystem of codecs or devices or protocols and so on. You have to ask yourself questions like, do I need to support Silverlight or WebM or MPEG-Dash? Do I need to optimize for content for smartphones or tablets, desktops or game consoles, Roku, smart TVs? I mean, there's so many devices out there. There's a lot of choice in the market, and the standards are not quite universal. So that presents a big challenge for publishers today. So let's just, for example, take the cross-section of smartphones. There's a large and disparate collection of smartphone devices that support really fragmented methods of streaming your media. So iOS, for instance, supports HLS, which is HTTP live streaming. The other types of devices that use Android, there is a variety of devices there. So all you really have there to go by is the software as the baseline when you're delivering your content to an Android device. There's also new devices coming to the market frequently, so you have to think about supporting these new smartphone devices and sort of the protocols that you need to deliver content to them. There's also multiple options when it comes to transcoding your content. There's a variety of different licensing deals made by various publishers. That adds to the complexity, and we think that this complexity will remain there for the next several years. In terms of the transcoded, the outputs of your transcoded files, there are multiple outputs that you need to match to various device profiles, whether that's the codec itself or the screen dimensions. And just given the large number of codecs and the large number of encodes that you need to transcode your content for, it just results in multiple asset libraries and increases your storage volume, as Mark had mentioned earlier. There's also really no true unified player to reach all of your viewers. Specifically, native players that are built into the various devices or smartphones, they offer a great out-of-the-box experience for viewers, but don't provide some of the value added or some of the features of functionality that the third-party players do. Things like customization or skins or analytics. Third-party players, however, need to be installed separately to the device, and that can cause the friction. So there isn't really a clear choice there, and that poses a challenge as well for content publishers. There's also no single way to secure your content. Mark talked about this a little bit. With digital rights management or DRM, you can specify policies that a player needs to adhere to. For example, deleting the chunks from the hard disk of the device once the video is played. But DRM support also differs by player and device. For instance, PlayReady works best with Smooth, whereas Adobe Access works best with HDS. So there's options and diversity there as well. There are also customers that instead choose to use token or policy-based security to restrict access to their content to authenticated users only. So that gives you as publishers yet another option to consider when selecting a security model for your content. And finally, there are other challenges, and these challenges sort of depend on the goals that you have as publishers and when you're delivering your media or video content to your viewers. So, for example, if you think about monitoring and just the content that you're delivering, you have to watch out for buffering, for error rates from your player or from the server side, so you can sort of meet your internal and external SLAs that you may have for the quality of service that you want to provide to your viewers. You also need to correlate these monitoring metrics to your revenue, to your drop-off rates, and other ways in which viewer experience can be impacted because of these operational metrics. You're also, from a monitoring perspective, you're also looking to identify shifts and trends. So, for example, you need to identify devices or operating systems that you need to re-encode your videos for. Or which content delivery provides the best possible performance in the key regions where your viewers are located. You also need to identify what content is popular in your library and take the actions that you may want to take based on that data. And then finally, as you work towards the different challenges or work through the different challenges, another goal that you have is to reduce your costs in this fragmented sort of ecosystem of video delivery that's out there. You incur costs as you work on lowering buffering to improve your viewer experience, or as you try and onboard a new device for which you may have to re-encode and manage the larger set of encoded files, or you identify a duplication in storage or processing or delivery of your content. So those are all areas where you need to reduce costs as you work through the complexity here. So one of the things that we've seen customers do from a sort of a traditional media streaming solution perspective is, given all of these challenges that are out there, customers often rely on building separate stacks for each sort of device or each platform that they need to support. So going back to our smartphone cross-section, we see, for instance, 3 different stacks for iOS, for Android, and for Windows Phone each. However, this does increase the complexity, the cost, and the time required to support new user experiences. So then customers end up making decisions that are potentially suboptimal to reach their entire viewer base. For instance, picking only the 1 or 2 platforms that you could support to reduce that complexity and cost. And this results in potentially loss of business by not being able to reach your customers on those other platforms that you are not supporting. Or it's just, it also poses a potential risk for the platforms that you have chosen losing their user base and that impacting your business. So now let's sort of talk about some of the media streaming best practices that we hear from customers. So again, looking back at the different components of the stack, starting with encoding, one of the best practices that we see customers talk about is and use is encoding to take advantage of sort of the commonality and the common configurations that are there that work for the widest range of devices. This helps with faster onboarding of content. If you can take advantage of sort of the common codecs and delivery protocols. This helps with less content that you have to manage and the overhead associated with that, and also reduces your processing and storage costs, of course. So as you can see in this chart here, from a codecs perspective, and this is something Mark alluded to as well, H.264 and AAC are sort of that common set of codecs that work across a variety of different platforms. And from a protocol perspective, sort of what's leading in the industry based on what we see right now is HLS, and with a little bit of smooth there as well, smooth streaming. You also want to avoid storage duplication. So this is something that I've discussed earlier in the presentation. This is the best practice that we see customers when they are trying to consolidate all their content. Today that content may be duplicated across disparate storage locations, and instead using a single central location, whether that's in the cloud or elsewhere, for all the different CDNs that you may have, or for the transcoding inputs and outputs and your storage. It just helps with manageability of content. It helps you scale better, and also offers you a lower cost. We frequently see customers choosing a cloud storage option like Amazon S3, which is AWS's storage solution, to do this, and we'll talk more about this in a few slides. It's also important to consider from a delivery perspective, picking sort of that right content delivery network. There are some fundamental things that you want to make sure that the content delivery network can provide to you. Things like global reach. If you have a global audience and your viewers are located around the world, then performance to all of those viewers in those different locations is important. So the global presence of the content delivery network that you choose, and the performance to wherever your viewers are located, becomes an important consideration. And beyond global reach and just sort of reaching those viewers with low latency, when you're delivering video content, it's also important that the content delivery network can provide a high level of throughput and low buffer rates and low error rates for your viewers, because those are really once the viewer starts viewing your video content, if the video is buffering a lot, or if they're seeing high error rates, that can really impact their experience, and their ability to watch the entire video. Also, some of the more subtle things like the content delivery network being context aware. And what I mean there is, being aware of the different devices and how those devices sort of stream content. And I'll give you an example here with CloudFront, the AWS's content delivery network. We worked with Roku closely in the past, where we noticed that Roku had some performance issues when we were delivering content to Roku devices, and we worked jointly with them to zero in on a specific way in which Roku requests are made. And we made some changes to our software, and that resulted in a very positive impact for our customers by us changing the way in which we handled the special case for delivering content to Roku devices. And then finally, just the visibility and the monitoring perspective, for your content delivery network to be able to provide you those customer insights and those access logs that you can process, and get meaningful insights for your users. The other, sort of best practice that we hear from customers is customers are often faced with this dilemma of, well, should they be relying on the native player or use a third-party player, or potentially both? And again, from the table here, sort of at a high level, outlines the pros and cons of going with either approach. There isn't necessarily a clear winner here. It really depends on your use case. But from a third player perspective, it does provide you the ability to customize, the ability to collect data so you can gather those insights about your viewers, and some of those factors that play in you being able to provide a consistent experience to your users. So we do see customers often choosing third-party players, to provide a customized experience to their viewers. And we actually have a webinar day after tomorrow, this week, Thursday, where we are talking about JW Player and how you can use JW Player with Amazon CloudFront. The other sort of best practice comes in the area of security. And again, there are multiple options here that we see customers use, and sort of depends on the use case. So customers will frequently pre-DRM popular content when they're encoding their content. So with this option, you don't need a packaging server in the delivery chain, but DRM support is needed in your encoder. So your encoder, in addition to transcoding and packaging for delivery, will also encrypt the chunks before storing the encoded files back. So this is a good option for popular content, but for long tail content, doing DRM on the fly is often a preferred option for customers because this allows customers to pay the DRM license fees only when content is requested. There's also CDN-specific private content features for authenticating and delivering content encrypted over SSL. And again, it sort of depends on how big, like Mark said, how big that speed bump needs to be, in terms of what security best practices you apply to your content. And finally, measuring viewer experience. There are a couple of different sources of data, and so the first is the CDN server logs, and that provides you information around cache efficiency, the popularity of your content, and any sort of origin-facing events. And there's also the real user metrics, and those give you details around sort of your viewer's true experience in terms of playback, buffering, or any sort of errors observed by the viewer. So most customers, what we'll see is they will frequently consolidate the above two different data sources, and to get that end-to-end picture for delivering their video and understanding the experience of their viewers. So at this point, I want to walk through a few slides that talk about using AWS to implement some of these best practices. AWS has a really well-formed ecosystem of partners and services and partners. Some of these partners are available in the AWS Marketplace, which is an online store that helps you find, buy, and use some of these software and services that can be run on AWS. And we have a number of media partner solutions listed on the AWS Marketplace. AWS services also offer you a cost-effective and scalable way to really manage your video processing and the delivery of that video by using services such as Amazon S3, Elastic Transcoder, Amazon CloudFront, and Amazon EC2. The pay-as-you-go pricing model is really designed to help you scale when you need it and scale down when you don't need the capacity. And then finally, AWS services do have media-specific capabilities such as the MPAA or the Motion Picture Association of America. They've established a set of content security best practices for securely storing, processing, and delivering protected media. And about a year ago, AWS infrastructure was deemed compliant with sort of all the applicable MPAA infrastructure controls. So that's another advantage, and you see the MPAA logo at the top right of this slide. From an encoding perspective, AWS offers the Amazon Elastic Transcoder, which is a media transcoding service for both video and audio content. And it's designed to be very scalable, easy to use, and very cost-effective in transcoding your media files. So the service, the Elastic Transcoding service, provides predefined presets that you can use to create media files that will play on a wide range of devices like smartphones or tablets, and some of the best practices that we reviewed earlier. You can also create segmented files and playlists for delivery using the HOS protocol to compatible devices. So it has a lot of those best practices already built in. It's really easy to use Elastic Transcoder. Actually, the Transcoder service provides you up to 20 minutes of free transcoding, 20 minutes of content each month. From a storage options perspective, there are multiple options available with AWS. The three that I'd like to highlight today are Amazon S3, Amazon Glacier, and AWS Storage Gateway. So Amazon S3 is an object store for file-based storage. and it can scale infinitely and provides high durability for your content. And a lot of our customers store their media content on S3 and use the S3 bucket that their content is stored in as the origin server for CloudFront distribution. Amazon Glacier is a very low-cost storage service that provides secure and durable storage for data archiving and data backup. So, with Glacier, customers can pay as little as a penny per gigabyte per month to store their content reliably. And then finally, AWS Storage Gateway is a service that we offer that connects your on-premise IT environment with the AWS cloud. So for things like remote office or small office applications, AWS Storage Gateway enables you to upload securely to the AWS cloud for cost-effective backup or file sharing or disaster recovery and things like that. So these three storage options is really what we see most frequently used by customers in the media industry when it comes to sort of consolidating their video content from a storage perspective. So this is another block diagram. I won't go into too much detail here. The slides will be available to you, but this again describes the architecture and the best practices of using the various AWS services that I talked about in the context of either on-demand or also live streaming by using services like Route 53, Amazon S3, EC2, and then CloudFront for content delivery. From a CloudFront perspective, CloudFront does support all of the HTTP-based streaming protocols, so HLS, HDS, smooth streaming, MPEG-Dash, and so on. CloudFront also has some of the video streaming specific caching optimizations, so things like range requests or fetching the file from the origin and how we sort of handle that, or optimizing the throughput for delivering your large video files to the various networks around the world. We're also a very data-driven company at Amazon, so we're collecting a lot of metrics around retransmits per megabyte or throughput and things like that and helping improve our content delivery network to improve the experience of your viewers. CloudFront has 43 edge locations today. The locations are listed on the AWS website, so you can take a look there. CloudFront does have, for example, for live streaming, joint solutions with streaming media ISVs. So folks like Adobe or Smooth Streaming or Wowza Media Server, and we actually have a webinar tomorrow with the Wowza Media Server folks, and we'll talk about how you can deliver a live stream using Amazon CloudFront and Wowza. And then finally, on the security piece with AWS, you do get the ability to restrict access to your content using Amazon CloudFront's private content features. These are policy-based ways to assigning a URL so you can authenticate users before they can download your video files. And also, encrypting your content using SSL end-to-end. You can do that with CloudFront as well, and use your own domain name when you're using SSL. With DRM, you can also secure based on content policies. There are different, a variety of different DRM platforms out there, such as PlayReady, Adobe Access, Whitewine, etc., and you can use those in conjunction with AWS. And the last thing is monitoring and measuring the customer experience. So CloudFront does provide W3C compliant access logs that you can download for your content delivery. So these are, think of these as more the server side, access logs. And then based on the video player that you use, you can also collect telemetry data for real user metrics that you can gather, and then combine both of these using tools that AWS makes available to you, such as Amazon Elastic MapReduce, which is a Hadoop-based service, and you can process your log data from both of those sources with meaningful insights that you can then act on. So I think that's really all that I wanted to cover, and I also wanted to leave enough time to get a few questions in. So I'll, at this point, hand it back over to Bowen or Jared, and Mark and I are available to answer any questions you have.
Thanks, Nihar. Before we get started with questions, I just wanted to remind everyone that we have 2 other webinars coming up this week that completes our series on streaming. So tomorrow we have live streaming using Amazon CloudFront and Wowza Media Server. That'll be at the same time tomorrow, 10 a.m. Pacific time. And then on Thursday will be the webinar using JW Player and Amazon CloudFront to stream HLS video. So that'll be, again, at 10 a.m. Pacific time. So we invite you to register for those webinars as well. And if you go to aws.amazon.com/CloudFront, you'll be able to see more information on those webinars, or click through the correct link to get the information. So right now we're going to go over some of the questions that we received through the webinar. Again, thank you for your questions. We have a couple minutes, so we'll answer some of those. The first question is going to be for Mark. What are some of the RTMP usage trends you're seeing?
Yeah, so relative to RTMP, this is a protocol that is primarily has been a proprietary protocol that Adobe used for delivering to Flash-based clients. And as I mentioned earlier, Flash is no longer really as available as pervasively as it was a few years ago. So it used to be that when everybody was just delivering video to PCs, Flash had penetration of more than 98% of PCs had the Flash client. Well, now that there's such a proliferation of devices available, the Flash client just doesn't exist on some of those platforms. So it's something that, while we still see it used for certain scenarios, most people for delivery of content to end-user devices are using these HTTP-based adaptive bitrate streaming protocols now. RTMP is still being used quite a bit, quite pervasively for delivery of live source feeds, maybe from production grade encoder into the origin server. So you can deliver RTMP streams of that source live feed into like an Adobe Media Server, and then have Adobe Media Server transcode and transmux that into an adaptive bitrate solution for further delivery onto the client devices. But that's the one area where RTMP is still being used fairly heavily. But like I said, most people are moving to adaptive bitrate HTTP-based protocols for client-side delivery.
Okay. Thank you, Mark. Nihar, this is a question for you. Are there any issues having a website hosted outside of AWS, but delivering media content from AWS CloudFront?
No, I don't, if I understand the question correctly, what you're asking there is your origin servers are located outside of AWS, so you're not using either S3 or EC2, but you still are interested in using CloudFront for the content delivery piece to your global viewers. And that's totally fine. There are multiple options available for where your origin servers can live. And CloudFront can talk to your origin servers either within AWS or outside of AWS, as long as the servers are available, over the internet. CloudFront can fetch your video files from your website or from your web servers and deliver to your viewers.
Okay, thank you, Nihar. One other question here. What are some things we can do to ensure high availability of our streams in addition to scalability?
From both an availability and scalability perspective, I think the best practice that customers have told us that they do is, and what we recommend also is using a content delivery network, a CDN such as Amazon CloudFront. Just by using a content delivery network, your availability is really amplified because the content delivery network nodes around the world are designed such that if there's an issue with one of the nodes, then your viewers automatically get routed to the next best location. So there's an inherent availability built in already, in using a CDN when you're delivering content to viewers. And then from a scalability perspective, I think, again, caching your video content at the CDN edge nodes can help provide scalability, because the CDN edge nodes are sort of the front line of defense when it comes to the peaks of traffic that you see for your video content. And the edge nodes will only go back to your origin servers when the content expires. So this really helps you scale out without necessarily investing in scaling your origin servers.
Thanks, Nihar. This question is for Mark. I have a lot of video content, studio scale. How do I get it into AWS? And how can I manage that large library cost effectively?
Yeah, that's a great question. Like we talked about earlier, the ingest piece is often one of the biggest considerations. So there's 4 basic mechanisms to get the content into AWS. So there's traditional transferred over the internet via something like FTP. Obviously going to be probably the least expensive option, but also not necessarily the fastest option. You can then kind of move up the scale to use software accelerated solutions. So we've got a number of partner solutions available on the AWS platform, things like Aspera and Signiant and Attunity Cloudbeam, and there's a whole host of these software accelerated solutions that use proprietary transfer protocols, UDP-based protocols, and that can really scale things up. I mean, I think across the public internet we've seen speeds with some of these solutions ranging up into the 900 megabits a second, and even a little more than that. So those are great solutions for a software solution. Moving up from there, you can actually, Amazon Web Services offers a service called Direct Connect, where we've got a number of convenient peering points around the world where you can literally directly connect your infrastructure into the AWS infrastructure via 1 gigabit and 10 gigabit ports and connections, and you can get as many of those as you really need, but that's a way where you can get a fat dedicated pipe to push content in. And what we traditionally see is a lot of people will use Direct Connect to blast a large library in very quickly, and then they'll kind of fall back to one of those software accelerated solutions for more of their incremental daily transfer needs. Finally then is just old school, ship hard drives to us and we can ingest those and ship them back to you. So that's another option.
Okay. Thank you, Mark.